Hi, welcome to Ask Less. A popular product used for compressed air blow-off is a flat nozzle. The way a flat nozzle works, I have one in my hand, is compressed air comes in, comes out of a gap, which can be holes or maintained by a shim, and it amplifies the compressed air coming out and creates an amplified flow by drawing in air from the atmosphere, thereby creating a laminar flow, which gives you a good blow-off force at a distance and also reduces energy and reduces noise levels. Now, there are many types of flat nozzles on the market, some made of plastic, some with holes in them, some that are maintained by a shim. So what is the best to use in an industrial application? These are the questions that you should be asking. These are the 6 points that would help you determine which one is best for your particular application. Some may be important for your application, some may not be. First of all, the material. The one I have in my hand is 316L stainless steel. It's ideal for food applications and for corrosive applications and corrosive environments. You have plastic ones that are available on the market. Plastic ones tend to be quite inexpensive, however, they can break easily as well. I remember a customer that actually replaced a lot of plastic ones with cast zinc ones because a lot of the plastic ones in their applications broke and someone actually got hurt because of it. So safety can be an issue if you're using plastic ones that can break easily and do break. So material can be a consideration. Secondly, does the air stay flat? We did a test some years ago, which was quite interesting, on some of the flat nozzles that are on the market. And some of them actually didn't stay flat. When you actually measured it about 12 inches or more away, it went round. So you actually got more of a cone shape as opposed to a flat shape. The next full one tested, by the way, fairly flat after a distance. So the actual profile can change with a flat nozzle depending on the design. So if it doesn't stay flat, that's important or not, that's something to consider. Third, efficiency. Flat nozzles that are designed with holes to let the air out are going to have a higher pressure drop. Similar with shim design. The next low one has an open shim. Some shims have sort of a sawtooth design, and those types of designs cause a bit more of a pressure drop, and you can lose some efficiency that way. Now, that may not be important in an application where you have maybe 1, 2, or 3, or 4 or 5 even of these units. But if you have 100 of these units, that efficiency difference can add up to a fair bit of money over the years. So efficiency is something that should be considered as you compare the different types of flat nozzles. Point number 4, flexibility to change. If I want to move the nozzle to another application, or in a particular application something's changed or I need more power, more force to blow off, or to eject a part, or I need less force, how do you change it? With a shim design, you can normally take them apart and either add or remove shims to adjust for the flexibility you need. With holes, you can't do that. So if you have a flat nozzle with a hole design, you're not going to have the same flexibility. Shim design, you're going to have much more flexibility. Point number 5, the actual power that you need. The next flow one tested to giving you up to 3 pounds of force at 12 inches away with fully loaded shims. That's pretty good. If you need that kind of force, the shim design is probably going to be better than the hole design. And finally, maintenance. What happens when a flat nozzle gets dirty? If you just have a hole design that cannot be taken apart or cannot be cleaned, you're not going to be able to clean that flat nozzle very well. So are you able to maintain the unit? Are you able to do maintenance on it if it gets dirty? It can be important. With a shim design, you can normally take them apart, like the one I have in my hand. So those are the points you should look for in choosing a flat nozzle. Material, does the air stay flat? The actual flow profile, efficiency, flexibility to be able to change, to adapt, the amount of power that you need, and being able to do maintenance on the item. Those are the things you can consider. If you have any questions concerning compressed air blow-off, using compressed air for blowing, cooling, drying, removing, ask less.